All right, so since we're having technical difficulties, I'm afraid we have to move on to our second topic of the day. Our second speaker is a mobile and backend developer. He is the founder of MyStore, a platform where you can sell your digital content and earn money. He hosts live Android sessions to spread the knowledge. Let us all welcome Mr. Rajesh Hadiya. Mr. Rajesh, the floor is yours.
Uh, yeah, hi. Thank you, Mark, and thank you, Kyla, for inviting me here. Let me share. Yeah, thank you. So, okay. So, thank you. I'm Rajesh from India. I'm an Android developer having around 4.5 years of experience building Android application as well as mobile development using the Spring Boot. Since 2 years, I'm using this Jetpack Compose to build Android UIs along with my professional career. Uh, I do host live sessions on various topics related to Androids, as well as I write technical blogs and on Medium, Hashnode, etc. Okay, so thank you for inviting me, and I hope this will be a great session. Okay, so let me just share my screen. Okay, so just let me know if my screen is visible or not.
Crystal clear, sir.
Okay, thank you. So in today's session, we are going to have a look at Jetpack Compose. First, of my introduction, I've already mentioned, and these are my social links. If you want to connect with me, I'm always open for connection. I'm on LinkedIn as well as GitHub. There's Hadiya Rajesh. Okay. So what is today's agenda? We will see what Jetpack Compose is, how it differs from XML, what is the compose structure, what are some basic layouts that Jetpack Compose offer, and what is the recomposition and states. Okay, so let me just hide this UI. Okay, so first, what is Jetpack Compose? So Jetpack Compose is a modern toolkit for building Android user interface, right? Since years we were using, since when Android was started around 2005, what we were using, we had two things. One is XML to create the Android UI, and the second was Java to bind this UI with the logic. Okay, so we were using two things: XML for building UI and Java to write our application logic. So these things lead to lots of problems, because it requires, first it requires a developer to have a knowledge of two things, that is both Java and XML. If you only know Java, you cannot build the UI, right? Because you need knowledge of the XML. Second, it was there were a lot of boilerplate code, and it was cumbersome. Building a UI with XML was a problematic. So that's why Google decided to create an entirely new UI framework for Android application in 2000. And okay, so that's when Jetpack Compose was introduced. So you can see it allows developers to create user interface using a declarative programming model, which means that they describe the desired state of the UI rather than specifying how to create it. So what we are doing is, in Jetpack Compose, it's a Kotlin exclusive, so you cannot write Jetpack Compose code in Java. Okay, so you must have to use the Kotlin. So with the Jetpack Compose, we are just ditching the XML. We are saying that, okay, we don't need another language to create our UI. So all of our logic, application logic, and the UI that we want to produce, that entirely will be written in only single language. Okay, so this will remove the barrier of multi-language, that is Java and XML. If you know the Kotlin, you are fine building with the application logic as well as the UI. Okay. This is different from the traditional way of building Android user interface, which uses XML layout files. So how it differs from the XML? The first thing is, in XML, developers write layout files that define the structure of the UI and the position of the different elements on the screen. These layout files are then used by the system to create the UI at the runtime. This can lead to a lot of boilerplate code, right? As I have mentioned, you first need to create XML files describing your UI, then you need to connect those files with your Java code, and then you need to write your application logic. like I want to hide this UI, I want to show this UI, I want to create make this UI circular, that kind of things. So there we are removing that thing with the XML. Okay, so with Jetpack Compose, developers write code using Kotlin to describe the desired state of the UI, and the system takes care of creating and updating the UI. So we have few concepts in a Jetpack Compose that we will have a look to understand how you can write the Jetpack Compose. So it entirely differs from the describing the UI using the XML, because it's based on the component based architecture. You may have heard about some component based architecture like React Native or Flutter, right? So what these architectures do is, instead of creating a plain like as a whole UI, we will create a single component for each UI, and then we will combine these components. Okay, so let's see what is the structure of the Jetpack Compose. So Jetpack Compose is a combination of 7 libraries. It's not something that's related to only UI. Okay, so it's a combination of 7 libraries within Android X package. Each group contains a targeted subset of the functionality. So Compose is divided into 7 libraries. They are not provided at the Android operating system level. See, in XML view, what happened was XML was provided at the Android operating system level. That means if you on your Android device, it knows, operating system knows that how to place this text view or image view or any view written in XML. But in Compose, the things are different. In Compose, they are not providing these things at the operating system level. Rather, they are giving it as a separate libraries, so that if there is any critical bug fixes or UI update, you can just simply update your library version, and you don't need to dependent on the whole Android operating system, that is Android 10 or 11 or 12. Okay, so the Compose is divided into 7 libraries. The first is compiler, second is a runtime, third is a foundation, fourth is a UI, fifth and sixth are material and material 3. Basically, material is a layout design developed by the Google. Okay, and material 3 is the successor of the material 2, that is written as a material here. So this material 3 is a successor of the material and introduced with the Android 12. If you have Android 12 device, you will see these things in action. Okay, and the last one is the compose.animation. So it will provide, this library will provide animation support to your applications. So okay, now we will have a look like how we can create the basic layouts. So you can see Jetpack Compose provides a set of ready to use building blocks to build UIs. Okay, some are text, button, text field, rows, column, and box. So as being developer, I just had like just presenting and I talk about the code, right? So let's go to Android Studio. So is like from the all the participants, do anyone has experience building Android applications? Hello. Yes, sir. Okay. Okay, Roland. Thank you. Okay, so this is Android Studio. Yeah, to create a Jetpack Compose project, what you can do, you can go to the file. This UI may looks different to you for the Android Studio because this is the new UI. So, but the steps are same. You can go to file, create new, and then new project, and you need to select these things. The name will be either empty activity or empty compose activity. Okay, select it. You will see this is the Jetpack Compose logo. Okay, so whatever the name is, you will see this logo. So just select this activity, click on next, fill your application details like name, package name, save locations, and minimum SDK, and click on finish. Okay, once you create the application, your structure, your Android Studio will create your applications like this. So you will have your Android manifest. Inside the Java, you will have your package name, and inside the UI package, you will have some files like colors, themes, types, and you will find this main activity created. This file is this is something what I have created, so you won't find it, but you will find all the files like this. Okay, and if you go to the build file, the build file will looks like this. Okay, this is a Gradle field file. And to separate the compose project from the XML project, what Android Studio do is it provides these blocks. Okay, inside the build feature block, you can see the compose equal to true. That means this project is a composable project. Okay, not the XML based project. So this is a composable project. So this line differentiate compose projects from the XML. So so Android Studio will create it by default for you. Then we have some dependencies. Android core lifecycle runtime activity. Okay, and this is something you someone of you might don't know. So this is a bomb based dependency management, that is a bill of material. This is a Apache Maven concept. So here we are providing the what we are doing, we are providing the compose version to only one bomb compose version, and for each subsequent dependency we are not providing the library version. Okay, so that means when we provide this version, all of the libraries that are compatible with each other, the system will automatically fetch it. So this is bomb based dependency declaration. So these are compose dependency, compose UI, UI graphics, and UI tooling. Okay, and the material, as you can see, we have seen in a structure. Okay, and compiler and runtime will be automatically included, and the foundation as well. Okay, so for the compiler, you have this compile option, a compose option, and inside you can pass the Kotlin compiler extension version. So this is basically compose compiler version. Okay, you can pass whatever compose compiler is independent of these dependencies. Okay, so you can use these dependencies with this bomb, but you can provide a different version to your compose compiler library. So you can specify that here. Okay, so these are overview of how Android Studio will create your application by default. So now let's see how you can build a UI with the Jetpack Compose. So as I've said, Compose provide different ready to use building blocks. Let's say we want to in XML, what we used to do, we used to create drag text view, button, and all those things inside your layout, and you will see those layouts here, like but in Compose, what we used to do, we write the Kotlin code to generate the UI. Okay, so and each composable function that generate the code must be marked with the @composable. If you go to this annotation, you can see that composable functions are the fundamental building blocks of an application built with the Compose. So keep in mind, whenever you want to produce any UI, be it a normal text or button or some complex UI like image view, etc. Okay, your function must be marked with the @composable. Then only it will output the UI. So I have created one function called main screen, and it is marked with the @composable. And inside, what I'm doing, I'm just getting this text. Okay, this is a function by the Compose library that will show the text. If you go to the definition, you can say high level element that displays the text. Okay, so now inside the text, it accepts some arguments. So first is the text, second is modifier. We'll come to it later. Okay, so for the text, I have written that hello from the Compose. Now in XML, when you drag and drop the text view, you can see the output in the output pane, right, from here, like how it will look. So to the similar thing in Compose is called a preview functions. Okay, so we have preview functions. Just give me a minute. Okay, sorry. So with the preview function, you can see how your UI looks, okay, without deploying it to the device. So in preview function also output the UI, right? So it should also be marked with the that composable. So here I'm creating a one preview function, and what I want to see, I want to see the output of this function. Okay, so I've written it here, main screen. So now if I click on this split button, compose will show me how my output will look. Okay, compose will show me how my output will look. So let's okay, so now I can see my text view will look like this. As I mentioned, this is a component based system and not the UI as a whole. In XML, what you do, you write everything like text and buttons and image view and spinner and all those things at a one. But compose is different. It's a component based system. You need to create your separate components. Okay, so let's say I want to show some text. So this is how it will looks. Now suppose I want to I want to build a button. I want to output a button. So compose provide a button composable for that. And this is on click method. If you want to see, if you want to show anything on when button is click, you can write it here. And inside this scope, this is, see, this is a button. Okay, this is a button, but button has some text, right? We want some text on the button, so we will use the same components called text here, and we will name it button. So now you can see this button will have some text when the rendering finish. Okay, let it just finish. Okay, so now you can see button has some text. So without the text, as I mentioned, component based system, without the text it will be a plain button, but you want some text over it, right? Like this button. So what you do, let me just close this emulator. So this is button, this is how it looks. Okay, with the button composable, and you want some text over it. So inside the content, we for this parameter content, all these parameters have default value, right? These don't have default value. So this content means we want to produce some UI on over that button. So we will write text, something like this. Okay, now let's suppose we want to build a text view, edit text view, where users can input their text. So compose provides one function called text field. Okay, compose provides some text field. So I'm just writing it uh, edit text field, and on value change, this is a callback. So when value change, we will come to it later, but when value change, we can provide our logic here. So let me first just show you how UI looks, and then we will interact with it. Okay, so you can see, we will see one text field as well here once this rendering finish. Okay, so you can see this is a text edit text field, right? So users can input some text here. Okay, and this is the preview pane. If you want to show these things on actual device, okay, if you want to see these things on actual device, you can see here this icon, and you can see run main screen preview, right? So you can click on this run button, and what happened, this preview, that means the UI produced by this function will be deployed to the device. So in XML you cannot do it, right? So in XML you can only see the entire device, entire UI deployed to device. But in compose, you can create such composable like this, and independently deploy them to device, to emulator, without installing your application. That means when I click on this button, your just give me a minute, your activity is not going to device. That means your application is not going to install, but rather the UI produced by this function will be displayed to the emulator. Let's see how it works. Okay, so now you can see we have this edit text field, right? And you can, you might think that this text and buttons are also there, but you cannot see it, right? You can only see the edit text field. Why? Because this edit text field is overlapping on both the button and the text. Okay, yeah, let me just let me just comment it out and deploy it to the device. So now we will see how it looks. Let's see how it looks now. Now you will see the text in button will be there, but this button will overlap the text. Okay, now you can see the text welcome, hello from Jetpack Compose, and button is there, but they are overlapping on each other, right? They are not, because in XML what we expect that in Java code, for example, we have written this line, and this line below it, it should be below it, right? But it's not the case with the Compose, because it's overlapping. Why? Here comes the fundamental building blocks of the Compose, that is row, column, and the box. So let's see how it works. Let me give you an idea. So in real world, what is column, right? In real world, what is column? What we, when we heard the column word, what we think? A vertical items, right? A list of vertical items. So for example, this is a column, and these are the vertical items from top to down, right? We think this as a column, right? Like from top to down, like this. We think this as a column, right? So and what about row? A list of horizontal items, right? We think about row as a list of the horizontal item. So if I were to describe how row looks, it looks something like this. From left to right. This is how rows and columns looks. Okay, so is this rows and column making sense for everyone, or do you have any question? This is
Yes, sir.
okay, great. So this is the physical world interpretation. This is physical world interpretation of the rows and columns, right? So this is how we consider rows, and we would consider this as a column. Sorry, this as a column and this as a row. So now apply these things here. We want a text field and a button below the text field. So what architecture will we choose here? A column, right? Because we want this as a text here, and a button below it, right? Button below it. So we want this text and then below the button. So we will use the column architecture. So Compose provide a composable function called column. You can see. So now you need to wrap your items inside the column. Okay. So now let's see how the UI looks. Uh, just in the preview pane. It now, because whatever you see in the preview pane will be deployed to the device. Both are identical. So let's see how it looks now. Now you will say you will be able to see both text and a button once it renders. I think it's not render yet correctly. Okay, so it's compiling. Okay, so once the preview render correctly, you will see that both text and button will be visible, and it won't overlap, right? So you can see the text is above and the button is below. Why? Because we are using a column structure for it. That is a list of the vertical items, one above and one below. Okay, so this is how you can build columns in a Compose. So now let's say you want to add some space between them. Now you can see they are some like let me add one property here, show system UI. So that way you can see how it looks on device. Inside the preview, if you pass this property show system UI to true, it will add, now it will act as a device screen. So let me show you that as well. Okay, so now you can see this act as a device screen, right? So we have this text and we have this button. So now let's say we want to add some space between them, or we want to now let's say we want to make them in the center. We want to place these things in the center. So what we need to do, we first need to ask this column to acquire the whole space. See, this is how, it's not about just code, it's how about you think about the UI. Okay, we want to make all these things in a center. So first step, what we will take, we will ask this column to acquire the whole space. And one thing to note, compose is a declarative UI. That means it will only do what you ask it to do. It won't do anything. If you just write the column, it won't take the entire space of the device, but it will rather take the space that is only required by its components. Okay, so it will take this much of space. So declarative means you need to explicitly ask it what to do. So first we need to ask column to acquire the whole space. So how we can do it? And now that means we want this column to acquire the house, acquire the whole device screen. That means we want to change how it appears. To change the appears, how your composable looks and feel, we have a concept of the modifiers in compose. Okay, so we have so modifiers are nothing but like you can say design properties that describe how your composable will look like. So you can change colors and backgrounds and all those things with the modifier, basically to describe how the user UI and UX of your composable will look. So first we need to ask the column to take the whole space. So how we will do it? If you go to the column function definition, you can see modifier here, right? It accepts a modifier and it accepts a default value. So even if you pass nothing, then there won't be an issue. Now I want it to acquire the full space. So what I will do, I will pass modifier equal to modifier dot fill max size. This is a function. Now we are instructing the column to fill the maximum size available to it. So what is the maximum size available to it? This entire device screen. Okay, so now we are asking it. Next, rows and columns. For rows I'll show you soon, but it comes with two things, arrangement and alignment. Okay, so in the case of row, arrangement is vertical, right? How you want to arrange it, like let me show you. In the case of column, what is the arrangement? Arrangement is when you want to show your item here, like at the top, at the center, or at the bottom. This is called arrangement. And in case of column, what is alignment? Alignment is horizontal, right? Alignment is horizontal. That means you want to these items, you want to show it horizontally here or here or here. For this is row. So we want to show items okay, we want to show items in the center of the sorry in the center of the screen here, right? So that means vertically center and horizontally center as well. So we need to ask the column to vertical alignment arrangement equal to arrangement dot center, and horizontal alignment equal to alignment dot center horizontally. Now if I run the code, let's see the preview how it looks. Now these things will appear here. Okay, great. So now you can see your UI is moved to here, because what is happening, see, and this preview will show me the exact composable as well. If I click on this button, it will show that this text is right. If I click on this one, on the ID, you will say this will be highlighted. See, if I click on this, you can see this is highlighted, right? And for the column, if I click on the column, if I click outside here, you can see the blue border around it, right? So what is this? This is a column. You can see the column is highlighted. You can see the blue border. That means it has acquired all the space of the device with this function modifier dot fulfill max size. And for the vertical arrangement, vertical means here, here, or here, and we want to make it here, that is center. So we are using this thing. And for the horizontal alignment, whether we want to show it here, here, or here. and we want to make it show it here. That means center horizontally. So this is a column work. Okay, now let's have a look about the rows. Okay, so rows means horizontal layout. So let's create another let me call it uh, a column view. Okay, so now let me create a row view for the same column. Let me make it a row view. Now in the row we will see items arranged in a horizontal fashion. So you provide composable function called row, and remove this column, wrap this code inside a row again. Okay, so with the row, just give me a minute. Okay, so now what happens is with the row, let's see how it looks. Okay, so this is a column view preview, and let me show the row preview as well. Let me comment it out because I want to only see the preview of this row view. Okay, row view preview. Okay, so now let's see how it arranged its child. These are the child, right? And this is the parent. So now see how it arranged the childs, and I'll show you. Okay, so now you can see it arranged in a in a horizontal fashion, right? Like this. Initially in the column the button was below the text, but in the row it is on the right side of the text, because this is a row layout. So the text will be this one, and the button will be this element at the right side. Now you can see they are not aligned, right? So in the okay, so now for the row we don't want to fill the maximum size, we only want to fill the maximum width for this. Let's say we want to fill the maximum width, so we can pass a modifier accordingly. A modifier dot fill max. You can see three functions: fill max, size, width, and height. So for the row we want to just fill the maximum width that is available. Width means this value, entire value. Okay, so now row has now row is of the maximum width. You might not see it. Let me show you. Let's render it. You can see the row is the maximum fill max width. Row has the maximum value, and we now in the case of the column, arrangement was vertical and alignment was horizontal. In the row case of the row, it's vice versa. Arrangement is horizontal like this, and alignment is a vertical. So we want to let's say we want to make it into center. So for the horizontal arrangement equal to arrangement dot center, and for the vertical alignment dot center vertically. So now these things will look cool. Okay, let's render the preview. Okay, let's just render the preview. Okay, so now rows acquire the max width, right? So it looks like this. Row view, fill max width, and horizontal is center. So row this is a row example of the row, right? And in the column it was below this one, but in the case of row it's a beside of this text. And let's say you want to add some space here, because you can see both of these things are have no space between them, right? This text and button. So what you can do, your compose provide one function called a spacer, and for the spacer we need to pass the modifier. So what modifier we will pass? This is a row, right? This is a row. So elements will be arranged in a horizontal fashion. So we want to provide some width here. If it's a row, we want to provide some height, that is from this one. For the row we want to provide some width between them. So modifier dot width of the, let's say 8.dp. we want to provide some 8 dp width. Now you will see that there will be some space between these two elements. Okay, great. So now you can see there is some space, right? Initially both of these things were connected with each other, but now with the help of the spacer, it provides some space between them, right? This is how you can provide some space between them. Now let me show you one example of how you can interact. Okay, so now we have created this UI, right? It's time to interact with them, because what is the use of the UI if you cannot interact with them? So let's build an UI where we will show one text and one button. Upon the clicking of the button, the text counter will be updated. So let me create that composable function for that view. If you just write the comp, Android Studio will provide a live template that will create a composable function for you. Just press the tab or enter, and you can provide a name, button click view. So inside this, what we want is, let's say we want this type of scenario. This is our UI screen. We want everything in the center, a button here, and a text view here. And when we click on the button, we want to update the counter of the this text. So everything in center, and now you can see this is above, this is below. Okay, so what layout will we use, column or the row? Can anyone answer? Hello? Column, Isabella. Yeah, perfect, Isabella, thank you. So we will use the column, right? Because this is above and this is below. So let's use a column for that. Column. Okay, let me use the same modifiers and alignment and horizontal, basically this entire view. Let me just do it. Okay, so now let's say we to hold this value, like we want to show a counter which will show how many times a button is clicked. Okay, so that means we need to store it somewhere, right? So let's go with the naive way first, and I'll show you why it not works in the compose. Let's say we are creating a Kotlin variable called counter, and we are initializing it with the 0. And inside the, and we, for the this text, let's say we want to show this counter value, and as this is an integer, let's convert it to the string, counter dot to string. Let's add some spacer first, and modifier equal to, as this is a column, we will use the height modifier. Let's say 8.dp. Okay, now but when the button is clicked, let's increment the counter. For this, let's see, let me create a string template, button click counter, and then write this code like this. Okay, so what is our expectation is, we will see this text view with the initial value with the 0, and whenever we click on this button, the counter should increment, and that means the increment should be shown in this text view, right? That is how many times we have clicked this button. So let me deploy it to device, button click view. Let me just copy it. Button click view preview. This is a random name. Okay, you can give it any name. Not it's not like that you have to use these names only. This is a random name. So if you let's now you can see the button click counter and button. So now we need to click the button, right? So let's deploy it to the device, and let's try to see if it works or not, because in XML this should work, right? We have the counter, whenever the button is clicked, we are incrementing the counter. That means this UI should update as well. Let's see in action. Okay, now we have our UI ready. Let me click on this button and the counter should update. Okay, you can see this is not updating. However, the times I update the click the button, you can see this counter is not updating. Okay, you can see this. I'm clicking on this button, but this is the staying the same. Why? This leads to an important concept in a compose called a recomposition. So there are three terms. First is a composition, a description of the UI built by Jetpack Compose when it execute composable. So this is our composable function. When this is executed on the device, it's called a composition of the UI. Second is the initial composition, creation of a composition by running composable for the first time. When we first deploy this preview to device, that means we have created the UI first. That means in the initial time, that is called initial composition. And the last is a recomposition, rerunning the composable to update the composition when the data changes. Let's say this data, what is the data in this case? This is counter, right? So we are changing the data. So when the data change, compose will redraw the UI where the data is being read. So in this case, this is data, and where we are reading this data in the text, right? In the button we are not reading it, we are writing it. So whenever, where are we reading this data? In the text. So compose will redraw the text. That is called recomposition. Okay, whenever the data change, compose will redraw the UI basically where the data is being read. So that means this text should update it, right? But you can see there is no update. It's a zero. Why? Because of the another building blocks in compose called state. So what is state? State is any value that can change over the time. This is a broad definition and encompass everything from a room DB to a variable on a class. So some examples are a snake bar that shows when a network connection can be established, or a blog post and associated comments. So what is a state in simple terms? Any value, basically any value that can change. In this case, you can see this is a counter and we are changing it, right? So this counter is a state. This counter should be treated as a state in compose. Any value, be it your API response or your local room data, or even your simple variable, any value that can change over the time should be treated as a state. So here we are changing the counter, so it should be treated as a state. Okay, now what is the mutable state? State is only really useful if it can change over the time. Okay, state is only useful if it can if this is a state and it's not changing it, what is the use of these things, right? If we can somehow make these things change over time, because with the increment we are changing it, right? Initially it will be 0, then we are making it 1 2 3 4, so it's changing. So state is only useful when it can change over the time. We need a way to change it, and we need a way to react when the change. So there are two types of state: a state and type variable T, a type that holds a read-only value and notify the composition when the value change. I'll come to it later, no worries. Mutable state is a subtype of the state that allows setting values. Okay, now what happens? See, understand, compose only understand the language of the states, not your, this is a plain variable. Okay, compose don't understand the language of the plain variable. It only understands the language of the state. So to store any value, you need to mark that variable as a state, and we want to modify it as well, so you need to mark as a mutable state. So what compose do? Compose provide one function called mutable state of, and now you can provide your value here. So initial, what was the value of the counter? 0. Okay, so okay, this is error that creating object during composition without using remember. Okay, so this is a standard error for developers, but I want to show you how it works. So this is a counter. So now you can call counter dot value, state as this components called value, which will give you the actual value, that is this one. Now, and compose will see whenever the state change, recomposition will occur. That means compose will redraw the UI. In this case, what happened? This is not a state, right? This is not a state. This is a plain variable. So even when we change the variable like this, counter plus plus, recomposition won't happen. And recomposition is necessary to update our UI. With this, recomposition won't happen because this is not a state. This is a plain simple variable called integer, right? Type of the integer, because 0 is integer, right? So, and compose only understand the language of the state. So you need to somehow make it a state, something like this. With the mutable state, we are making it as a mutable state, and you know, mutable state extend the state. So this is a state basically. Now we are incrementing its value. Now let's see what happens. Now let's try to deploy this. We have created the state. We are updating the state. As the state is updating, this text should update as well, right? Because compose react to the change when the state updates. So let's see how it works. Now we have this counter as a variable. Okay. So, okay. So, we need to use a value here actually, because this is object location. So let's just use the value to get the actual value of your state. Okay, so now we have this UI, text, spacer, and button. Let me click on this button. Okay, I'm clicking on this button. I'm clicking on this button, but still you can see UI is not updating. As you know, state, I'm updating the value. That means state is changing, right? State is changing, so recomposition should occur. But I am only seeing the 0 value. Why? Because with the fact that and what is the recomposition? Just redrawing the UI. So let me show you how it works and why this is not working. So when you click on this counter.value plus plus, that means state is changed, right? So compose will know that, okay, there are some state change, I need to update. It will start from this line, basically from this function, from the first line of this composition. What it will encounter? That it will encounter that, okay, this developer is asking me to create a mutable state of the 0. Then it will create the column. It won't basically create the column because it's not reading the state. It will update this value, but while updating the value, see what happens. When it start recomposition from this line, from the first line, it will know that, okay, this developer asked me to create a mutable state of 0. Let me just create it, and we are reading it here. So so it will produce the 0. Okay, and it will produce this UI. Now if I again click on it, state will change, but when the compose will start recomposition from this line, this will encounter it will encounter this line. Okay, so now it will again think that, okay, this developer is asking me to create a mutable state with the 0 value. Okay, I have created it. Now let me show it. So it will show the 0 value. You know, the cycle is going on. It's just iterating over this value. Whenever recompose happen from the first line, it will encounter this line. So it will make your state will always have this 0 value. Now we need to work around it. So we need to somehow tell compose that, hey compose, when you encounter this line, do not initialize it every time, rather remember it. Only initialize it for the first time, and whenever then I update it and recomposition happen and you find this line, do not reinitialize it, rather remember it and update it accordingly. So that's where remember API comes. So what is this? Composable functions can use the remember API to store an object in a memory. A value computed by remember is stored in a composition during initial composition, and stored value is written during recomposition. So what will happen if we use the remember API? It when the first composition happen, that is initial composition, that means your UI is shown for the first time, it will calculate the value, it will store it somewhere in the memory, and when the recomposition happen, it won't re-execute this line, but will get the same value from the its memory. Remember can be used to store both mutable and immutable objects. So let's you know, this is why ID is giving error. What is the error? So let's see. creating a state object during composition without using remember. So we need to ask compose that, hey compose, just remember it, don't re-execute it. Okay, so you can do something like this. Now sorry, now what happen, compose will, when the first UI will display, compose will remember this state, and whenever we update the state, compose won't re-execute line and reinitialize, but rather read its value. So let's see how it looks now, and are we able to finish our UI or not. Now compose will remember it value. So let's see how it works now. Let me just deploy it to the device. And okay, so initial, okay, so what happens, see, this UI is shown for first time, right? So what compose will do for the initial composition, it will calculate the value. That means it will assign a 0 value. It will remember it that, okay, when I have this variable called counter that I need to remember it. So it will store this 0 value for this counter in memory. Then it will create this UI, create this UI and this UI. Now let me click on button. Okay, you can see +1, right? You can see 1 here. Why? Because when I click on it, counter value incremented. Counter value incremented, that means compose will draw the compose will start the recomposition. It will start from the first line, then it will encounter this line. Now we are using remember, so compose will know that, okay, I don't have to reinitialize it, but rather read the value from the counter. Okay, so what was the initial value? 0. And what we are updating? 1. So we are using a increment, so it will update this counter state to 1. Then it will draw this UI. So now you can, and where are we reading it? In the text. Okay, so it will redraw this text, so you can see the 1 value with the updated. Again, let me click on button. You can see this value is updating, right? Click counter 9 10. Okay, so these are the essential components basically with the UI. So these UI building blocks are to design the UI, and states are to interact with the UI. So you need to keep these things in mind. That is this will describe your UI, how it will look, and states will hold the value that your UI is showing. Okay, so you, and you need to remember one thing, that compose only understand the language of the states, not your normal variable. I've shown you, right? You can, if you do something like this, this is not a state, so compose won't update the UI. It will only update the UI when you provide it a state. And to avoid reinitializing the same state, you need to wrap your state inside a remember block. If you go to the definition, remember the value produced by the calculation. What is the calculation? Anything that is inside this block is a calculation. This is the calculation. Calculation will only be evaluated during the composition, that is first composition. Recomposition will always return the value produced by the composition. So this is how it works in a compose. Okay, and what is the last thing? These are some examples to create a state. For example, you can create a state like this, remember, and then mutable state of value, or you can use a by. This is a Kotlin delegation to get the state. I'll show you how. And then this is the destructuring declaration property of the Kotlin. This by and this thing has like no relation with the compose. It's just a Kotlin properties, not specific to compose. So let me show you this thing, where while. Okay, now we are creating state like this. Okay, so you will notice that you need to create a call dot value, right, to get the actual value. If you just call the counter like this, its type is the mutable state, and to get the actual value you need to call the value. Now if you want to directly get the value, you can do declare your state something like this. Instead of equal to, you can use a by. By is by the way Kotlin keyword to for the delegation. Let me import some functions. And okay, I think I have imported get value and set value. Okay, we have set value and get value. Okay, so now you can see this value is in red, right? because now it won't return the state itself, but the actual value. So you can just call something like this. You can call something like this, right? This is internally, it is still state. It's a still state, but just for your reading purpose, it will return the value. It's a still state, but for your reading purpose, it will return a actual value. Now you don't need to call the value, and you can just call the variable name. So let's try and run. So it will produce the same output. It's just that we are reading the direct value instead of the mutable state. Okay, so it looks cleaner, right? uh, okay, so now it can you can see that value is updating, right? And we are reading the value. It's just that for our reading purpose, it's still a state. Okay, so now okay, so okay, I can see in chat column. Okay, so I think I may want to cover one more thing, but may I ask the organizations how much time we left? Hello.
Um, okay, I'll check on it here. I think we still have
15 minutes around, I guess.
15 minutes, sir.
Okay, great. So let me quickly show you another magic so of the compose that, and you will wonder why it's not working. So let's create a text field, that is edit text field in XML. Okay, so uh, text field has some value, right? We need to and when user type, this value is changing, right? When the user types, this value is changing. Or so let's do something like this for the first. Okay, so this is experimental API. Let me opt in. Okay, so now in your XML view code, what you expect? You have created your edit text field, and this is a text field is similar to edit text field, and you allow users to write something, right? So let's try to build that UI. Let me add a spacer of the more. And by the way, one thing you can, and as I have shown you, Compose is a component based architecture, right? So with the height, what we are creating a vertical spacer. So you can do something like this, vertical spacer, a function, and what it will return? It will return the spacer. Apply. It will produce the spacer, and you can provide the size here, integer. So you can call the size.dp. We are using height, right? So vertical spacer. And so instead of writing this every time, you can do something like this. It will do the same thing. So let you just have to your divide your things into components. So for the vertical spacer, I just created a function that will provide some vertical space. So for this, I want to add, let's say 16. So let's try and run. These things ignore for this this deployment. I'll explain soon. Okay, so now if I deploy the preview to device, I'll see one text, one button, and one edit text field. And let me write something on edit text field. Okay, so this is, but this is working, right? 1 2 3 4 5 6. Now this is a text field. Let me write something. See, I'm writing RT. You can see nothing is going on, right? And this is like a strange for if you coming from the XML background. This is strange because it should write whatever I want to do. Okay, but it's not writing. Why? Because as I mentioned, Compose is a declarative UI. You have to explicitly tell it what you want. So what we want, when I write R, I want R to be shown here. When I write A, I want this RA to be shown here, right? That means this value is changing. And what is the concept in Compose we use when the value is changed? Of course, state, right? So we need to create a state and we need to remember it. So let's say where a name, let's call the name by remember mutable state of this mutable state of this is a string, right? So we will create an empty string. So we need to pass this state. The text field will take this value parameter. So we need to pass our value in a value, and when we press the R or anything, when we press any button, this callback will be called, right? That value is changed. Compose is asking us that okay, something is changed, you do whatever you want to do. So when the value change, what we want to do, we want to update this name, right? We want to update this name. So it provides a string value. It provides a, on value change, it provides us a string with the updated value. So let me call it a value, and when the value change, we want to update the name equal to name equal to value. Now see what happens. Let me show you in action. Now it will work expectedly, and I'll show you how. Let's just build it. Let me just build it. Button counter is working as expected. Now let me write R A J E. So it's working, right? Why? Let me show you. When I type the R, Compose will call this callback method. That okay, something is changed. You may want to do your action on or on. So as a developer, I want to update this name. I will update the name with the value I got from the Compose. Okay. Now when I update the name is a state, right? And state is changing. So whenever state change, Compose will do the recomposition where the state is being read. Where this state is being read? Here inside the text field. For the value we are reading this state, right? So that means it will update the text field with the newer value. When I press the A, Compose, this value will contains the RA. So I am assigning this RA. Let me show you. I am assigning this RA to this name. The name is changing. So that means this property is reading it. That means the text field will be recomposed. And when it recomposes with the new value, you can see RA here. So this is how the things are going on behind the scene. Okay. So this is how Compose works. So this was the basics of the Compose that you need to keep in mind, like columns and row default composables you can do, or you can create your own composable like this. For example, for this vertical space, we have created this function, and to interact with the UI what we have created, we need to create a state, because Compose only speak the language of the state. We need to create the state, or your see you for the state you can create anything. Let's say I have data class person, and name string id, or just well like this, and well address. Let's say this is this. It's a string as well. So I'm reading. I'm reading this. Let's say I'm getting this class value from the network or from the local DB. So I can create state for that as well, right? Let's say person by remember mutable state of. Let's say I don't have initial value, for I can create a null value. Okay, and what is the type? Type is the nullable person. Okay, so I can create something like this as well. So what is the type of this person? It's a nullable person class. So any value that change over time, be it your class or simple primitives types or anything, be it your network data or a room, anything that change, basically you need to create a state of it with the function mutable state. Provide the initial value if you have, or just null, and make it nullable like this, and you need to remember it. So Compose don't re-execute it every time. Okay, so these are some examples of the state. This is destructuring declaration. so you can have a look, because I think not everyone is on the like familiar with that much of Kotlin, so I'm just keeping it. So okay, so that is always what I wanted to talk. So thank you everyone, and you can shoot your questions if you have them.
All right, so there you have it, guys. Thank you so much, Sir Rajesh, for opening this conversation about Jetpack Compose, etc. So, uh, at this juncture, we will now proceed to our open forum. So, participants, if you have any questions in mind, this is the right time for everyone to jot down their questions in our local Zoom chat box. And as for our audiences in the Facebook Live, we have Mr. Joseph Natividad as moderator. So, to each and everyone, we are ready for your questions.
Okay, so the first question is from Roland, that is as a Kotlin learner having a slight interest in using Jetpack Compose as a junior developer, how can I compare Compose to development tools such as Flutter or XML for the instance? Okay, so to compare the Compose and XML, the things are very clear. With the XML, you need to write the boilerplate code. With the Compose, you don't need to. With the XML, let me give you an instance of the recycler view, right? If you want to load the list of the items with the XML, what you need to do, you need to create an UI for single item. You need to create your recycler view in Java. You need to create your view holders. You need to create your adapter. Lots of messy things, right? With Compose, this is very simple. Compose provide one API called lazy column. These are called lazy layouts. Okay, my screen is still visible, right? So Compose provide this called lazy column. This is equivalent to your recycler view, and Compose provide lazy row as well and lazy grids. So with the around 10 lines of code, you can create your recycler view will be ready in a Compose. So you can avoid the boilerplate code. That is first thing. Second is a where did my things went? Yeah. Okay. So second is uh, predictability. You can always decide how your code should look by manipulating your state. So Compose is always better to the XML. Okay. And Google has announced that they will focus more on Compose instead of the XML. So this should be a good milestone to understand that Compose is going to be the future. Now talking about the Flutter and Compose. Flutter is multi-platform device tools, right? Okay, that's great. And also, I'm not saying that Flutter is not good. Flutter is also good as well. But Compose, with the Compose, what they are planning is Compose is currently available on Android, web, and desktop. Okay, so with the same composable, you can create your desktop application, web application, or Android application, and they are planning to migrate it to iOS as well, right? So with the Compose, you will be able to write the same code for the Android as well as iOS. So that is the benefits of the Compose. Flutter also do provides the same thing, multi-platform UI creation, but Compose is exclusive to Kotlin, and Kotlin team is also working on another big project that is called Kotlin multi-platform for using Kotlin everywhere, be it web or desktop or mobile. So Compose perfectly integrate with the Kotlin multi-platform. So I would recommend to go with the Compose. But if you have need of, to learn the Flutter is fine as well. Okay, thank you. So as someone who is primarily Android JS dev, do you have any tips in regards to transitioning from JS to KT? So yeah, Kotlin provide JS means you are asking to write JavaScript, right? So for the Kotlin, it has support for the JavaScript as well, because Kotlin with the Kotlin JS artifact. But this is something I'm yet to touch upon, because I use Kotlin on mobile as well as a desktop platform, not on the web platform. So this is something I'm yet to touch upon. So you can always have a look at the Kotlin documentation. Okay. Got it. Thank you. Okay. Anyone else?
Okay, so for our participants, we still have 10 more minutes for our open forum. And if you still have any questions in mind, this is the right time for you to ask them. So keep them coming. We are ready for your questions.
Right. Perfect. And while the questions come, let me show you one thing. I'll if you have a question, let's say now what we are currently doing, we are deploying this, but we can deploy our own app as well. Let's say this is our main activity. Okay, so let me run the main our application instead of this discrete UI. Okay, so if you have a question, you can just shoot. I'm just showing it because uh, and we don't have to wait. Okay, so that means what this application is doing is called this greeting function. It's a composable function, so it will takes the it takes the name parameter. So you can see the hello Android, right? So this is our application. Then and these were our just preview function. So this is our entire application. You can just we have launched our main activity. So that is something I wanted to show. Okay, aside from the Android Studio, is there any IDE in particular that is easier to code KT on? Yeah, so if you want to particularly write code for Android, I would recommend Android Studio because this is official IDE. So of course it has the best support. But if you just want to write the Kotlin code, be it a JS or a desktop application or your backend application, right? Because Kotlin is everywhere. So I would recommend JetBrains IntelliJ IDEA because JetBrains is the same company who invented this Kotlin language, right? So of course their own IDE will have the best Kotlin support. So I would recommend JetBrains IntelliJ IDEA. That is IntelliJ IDEA. You can down there are community edition available as well, so you can download it for free. But if you want more features, you can download the paid version. So you use this IntelliJ IDEA. Apart from that, there are Eclipse and NetBeans, but I wouldn't recommend it because in my professional journey, I found that IntelliJ IDEA is the best for Kotlin and Java. So go with this IntelliJ IDEA. Okay. Yeah, thank you, welcome. Okay, any more questions? You can ask about anything like whether how you can do some specific thing on Compose, or how it works, or something like that.
Do we have other questions from our participants? If there's none, then I guess that sums it all up. Thank you so much to our participants, to each and everyone for participating in our open forum. And unfortunately, I guess that's the end of it. I hope you all have learned and discovered something new, because this discussion here about Jetpack Compose is very new, especially for me. So I think this is something that I could bear in mind from the future, for myself, and I really think is very useful, so to speak. So thank you so much, Sir Rajesh, for opening this conversation. So
Thank you for having me here, and it's my pleasure to uh, teach you about the Compose.
at this juncture, we will be proceeding to the giving of certificates. Mr. Rajesh, if you don't mind, we would like to share screen on our end.
Yeah, sure. Let me just give me a minute. Let me connect my webcam. Okay. Uh, yeah, thank you. Yeah, please go ahead.
With deep appreciation for your insightful presentation and visionary guidance, we present a certificate of appreciation to Ms. Rajesh Hadiya.
Thank you.
Contribution as a resource speaker in the first day of the GDSC USA's Move Up and Intro to Android App Development with the topic Introduction to Jetpack Compose, given this January 27, 2023 at the University of San Agustin, Iloilo, signed by Ms. Carla Aliyah Ortega, Chief Executive Officer of the GDSC USA, and Ms. Maricel B. Salazar, GDSC USA Advisor. So thank
Yeah.
you so much, each and everyone. Before we proceed, we encourage everyone to kindly please switch on their cameras for the photo taking session with Mr. Rajesh Hadiya. Technical team, kindly please count from 1 to 3 so we will have our best smiles ready.
Just can you just give me a minute so I can connect my cam.
Yes, sir, you can take your answer.
Just uh, just give me a minute. Mm, so I think there is some technical difficulties in my cam, so unfortunately I won't be able to turn on the camera.
You can take your time, sir. We will wait for you, sir.
So let me just give it a last time.
Okay, so while waiting for Mr. Rajesh, kindly prepare yourselves, guys, for we have prepared games for you, and I hope everybody is ready, so to speak. So good luck to each and everyone.
Okay, so it should be fine now, right?
All right, so we are ready right now. So Mr. Technical, we are ready for the photo op. Kindly count from 1 to 3. So we are ready for our.
Okay, guys. 1, 2, 3, smile. One more. 1, 2, 3, smile.
And that concludes our topic about Introduction to Jetpack Compose. Thank you so much once again to each and everyone. To Sir Rajesh, thank you so much for being our resource speaker, and we hope to see you in the near future.
Thank you, Mark and Kyla, for having me here. I'm looking forward to have more sessions with you in future. Okay, thank you. Bye bye. Have a good day to everyone.